Hello everyone, welcome to Biopython tutorial. So today we are going to explore how to read FASTA and GenBank files, then how to access feature, location and position objects. So let's start with the quick overview. What is Biopython? So Biopython is a powerful tool for computational biology, and one of its core module is bio.seq.io, which is we are going to use to read and write the sequence data in a various format like FASTA and GenBank for today. So let's begin with the FASTA file. What is a FASTA file? So it's a simple text-based format for representing nucleotides or peptide sequences. So each record in FASTA file start with a description line. So let's import the module. Oh, before begin this, if you haven't installed the Biopython, you can use pip install Biopython. So this is the command you can use through your terminal and you can install the Biopython. So let's import the module. So from bio import seq.io and hit enter, then record equals to seq, then record equals to seq.io dot read in bracket. I'll provide the link in the description. You can download the file from there and you can use the same file, or if you have another file you can use that as well. Okay, so we have given the path over here and we have mentioned the format of the file. If you are using FASTA file, then it should be FASTA. If you are using GenBank file, then here should be a GenBank. Okay, let's print record. So this is how it look like, the FASTA file. So it is important to note that this function we have used here, .read function, it only reads the single record. Okay, if your file is containing multiple records, it won't read. Then we need to use the parse function. So we'll see in the future videos how to use that and when to use, but at the moment, since we have a single record, so we are using .read function. If you have multiple, then just change and here put parse function. Okay, now let's see how to access the key attributes. For example, record.id, I want to access the id. So here you go, then record.description, here's the description. Okay, so in this way you can access all the attributes. Record.annotations, you can say it's empty. Okay, why? Because FASTA files are designed to be simple text-based format for representing nucleotide or peptide sequences. So these files are very simple, as you can see. It's easy to read, it's a human readable format, but it's very simple. So, and it does not include detailed annotation or feature about the sequence. However, the GenBank files allows to have annotations and feature. So we'll read the GenBank file and let's see how it look like. So record seq.io.read. So again, this is a file path and the format of the file. So previously we used FASTA, now it's GenBank. So this is how it look like. Here you can see ID, name, description, database, then different attributes like date, data, topology, keywords, features, so on and so forth. Let's go and let's see record.id, same, record.annotations. Here you can see the annotations, molecule type, topology, date, accession number, so on and so forth. For example, if you're looking for particular attribute, so you can say a record dot annotations, and you can mention what you are looking for example date, and here you can, so in this way you can access the particular attribute what you are looking for. Then you want to access features, record dot features, so you can see there's a long list of feature. So if you want to access particular feature, then you can say record dot features, and you can access that. And if you want to know the length, then record dot features. Okay, so total is 41, so you know, you have the idea, like there are 41 features, and then you can access whatever you want. So that's it. That was the overview of how to read FASTA and GenBank file in Biopython. Moving forward, in order to access the feature, we should know the location and position of the object. So for example, if we want to annotate the particular sequence from the parent sequence, we should know their location and position. Okay, so since we have only used the simple positions, so now let's see the fuzzy position. So there's a concept. For example, if you are doing a dinucleotide priming experiment, where you discover the starting position of mRNA, so no, where it start on the side, but you are not sure that which is the starting position, or you're not sure that which is the ending position. Okay, so in that situation you can always use the fuzzy position method. Here we import the module, then there's the start position and the end position. So in this feature, the starting position is after 5, so we'll take here 6th position from the sequence, and the end position is 9, so 9 is the reference, but again it's not sure, it may end at end or it may end at 9th position. So you know, that's how this fuzzy position work. And then we print the my location. So let's see the attributes. My location dot start. Okay, then my location dot end. So here's the starting position, ending position. So we are assuming we already have the feature position, and then we are accessing through that the starting position and the ending position. But if you don't want to deal with the fuzzy position, you can use int and my location dot start, again int my location dot end. Yeah, so here you can see you get the left and right position as well, but when you don't want to deal with the fuzzy position, then you can get this result. Okay, let's see the example of exact location, and then we'll move forward for local location testing. So here exact location equals to, let's say, sig feature dot simple location, let's say 3,9, and then print exact location. This is how we get the start position and end position. Okay, moving forward to location testing. So let's see an example. Suppose you have a SNP of your interest and you want to know which feature this SNP has, and you have a SNP index. So you can access what kind of feature this SNP has. So let's try. Here we are running a for loop for feature in record if my SNP in feature print in bracket what do you want to print feature. So in this way we can access the feature.